So welcome to our next course. This time we are going to talk about Kubernetes in the context of machine learning deployment. Kubernetes, which will help us standardize application deployment and management, which is very important in large-scale deployments and is very often used in machine learning pipelines deployment. So let's dive into the basics of the technology. So the most important benefit and the main goal behind Kubernetes as the idea, as the system, is to abstract away the infrastructure from the developer. So imagine that you would like to install your app, whatever app it is, on hundreds of computers. Yes, these computers may run on different operating systems and different versions of those systems, etc., etc. Obviously, you may have at the moment you may use different tools for that, but there is also a possibility that a user will invoke, for example, SaaS system by herself or himself, yes, and then there's a question how to deploy it, yes, how to deploy it, where to deploy it. So in the typical use case with Kubernetes, developers or operators deploy applications via Kubernetes. This is the shortcut for Kubernetes K8s, yes. So they know there's no need to talk to computers by themselves. So this is the idea of the abstraction. Kubernetes does the job for developer. Moreover, you may standardize application deployment because applications are deployed declaratively using configurations YAML files. Yes, so the developer provides a description of the app design. Okay, for example, if the app is created as a set of microservices or containers, you may describe those connections in the configuration file declaratively, and then Kubernetes turns it into a set of running components for you. Yes, so this is your app, and Kubernetes turns it into a set of running components and ensures that components keep running. So restarts them, recreate, scale in case it is needed. So there is all the infrastructure aspects are hidden from you as a developer or operator. Moreover, sometimes you may change your app description. So for example, substitute some other component by the other one. Yes? Some one component by the other one. So you change the description in your configuration file and Kubernetes does the job for you. So in case you change the design, Kubernetes transform running components, starts new components, and stops remove components. Okay? So this is also very interesting way of standardizing application deployment. But there is also, as I said, no need to use each provider's proprietary API to deploy and manage apps. Previously, before Kubernetes, if you had your own app and you wanted to deploy it on Amazon, you should use different scripts compared to deployment on Google Cloud or Microsoft Azure. Now, since all of those providers, not only them, but also some other providers, have Kubernetes in use, okay, so they provide you with the universal API, so you create your own app once, you declare the deployment in the configuration file, and then you pass it to the given cloud provider. So you can move easily your applications between different cloud providers. So this simplifies your job in case your applications are complicated. Moreover, and this is the dream for operators, yes, ops, you do not need, there is no need, almost no need to daily manage your apps because Kubernetes will take over the management. You as a dev or op tell Kubernetes what do you want to achieve. Yes. So, for example, what should be stability of the app, how to scale, how many different so-called pods you want. Yes, we're going to talk briefly about pods later on. Okay. Kubernetes will perform necessary actions taking into account the current state of the environment, applications, and infrastructure. So it can also help you to keep applications running smoothly. So if given app crashes, Kubernetes will restart it automatically. Moreover, it will automatically adjust to changing loads. Kubernetes monitor and adjust the number of running instances of each app to cope with increased load. So it can even increase the size of your cluster by provisioning additional nodes from your cloud provider. So this is key for scalability. We're talking about at one of our first lectures. So you tell Kubernetes what do you want to achieve, and it performs necessary actions. Take into account the current state of the environment. So let's dive into the Kubernetes architecture still at the very high level. So firstly, Kubernetes exposes the cluster, your cluster, your set of servers, yes, via APIs as a uniform deployment ecosystem. So apps are deployed by Kubernetes API and run across all the machines in the cluster. A given app may be relocated from a server to server if needed, okay? But it's behind you because Kubernetes abstracts away the infrastructure from you. So, and this is the key point for my lecture, you may think about Kubernetes as an operating system to the cluster. And now look, this is quite nice intuition. Imagine that you have at the moment your computer with some operating system that may be Windows, that may be Mac, that may be Linux, whatever. The role of operating system is to abstract applications from the hardware. So, for example, you run a browser at the moment or Microsoft Word, whatever. You as a user use this app, and then operating system takes care about assigning a different hardware and services processes running in the background. For example, the memory, CPU, disk, connections like Wi-Fi or Ethernet. It's abstracted away from you. Yes. So it takes some request, does the job, and returns the answer to you. Yes. So this is the interface between you, your app, and the hardware. So you may think about the Kubernetes as the same, but with servers here. So you have a request on running a given set of apps or given app somewhere. Yes. So Kubernetes takes this request from you and then manages the load of this app, running the app on different servers. So this is your local computer. This is your local cloud. Yeah. Maybe not cloud, but cluster of servers. Kubernetes does the job for you. So keep this intuition with you. It will help you navigate in a very, very complex world of Kubernetes. So how is it constructed? So you have two main concepts in Kubernetes, so-called control plane, workflow plane as a way to control master nodes and worker nodes. So computers in a cluster managed by Kubernetes are divided into the control and workload planes. Control plane, in many cases it's just a single server, is the brain. Yes, is the brain. Worker nodes do their job. They run your applications. Okay, so this is what's going on in the background. So have the brain and workers. So control plane, the brain has the following structure. This is the single API, yes, so you talk only to this API server. This is a scheduler, these are some controllers, there are some worker nodes, and the etcd protocol, yeah, so this is the control plane. So dev and ops create objects via API. Scheduler assigns node to run each instance of a given app. So it assigns nodes. Controllers perform many different tasks. So for example, when you set up your first Kubernetes cluster on bare metal, you'll probably have to configure a lot of different controllers. It's quite difficult stuff, but it becomes easier and easier from the release to release. Yeah? Worker nodes communicate only with the API server, so you do not have direct contact to the worker nodes. API server is stateless, so it stores objects in a distributed data stored. So this is etcd. Okay, this is the control plane. Workload plane, as I said, communicate with Kubernetes API server directly. You have worker node where you have the following objects. You have the kubelet, container runtime, and kube proxy. Kubelet is the node's agent. So this is a kind of the server worker node, yes, which does the job. There may be plenty worker nodes in your cluster, yes. The kubelet is the agent which communicates with the Kubernetes API server. Kubelet instructs the container runtime, for example Docker, but as I said previously, Docker is not the only container runtime. There are some others. So, for example, in different deployments of Kubernetes, you may also encounter some other specific non-Docker container runtimes. But generally, kubelet instructs the container runtime, like Docker, to run the apps and get their status. So you have the interchange of information. This is the command from kubelet to container runtime run something, and this is the info about the status of this run. Applications run in containers, as we know from the previous courses. And the kube proxy creates a virtual load balancer for each app that needs it. So sometimes the applications need load balancing, so kube proxy creates such a virtual load balancer for those apps. So this is the architecture of the worker node, obviously from the high-level perspective. Now the next very important concept, when you manage a Kubernetes, you will find many different ways of running, stopping, managing so-called pods. Pods are group of containers. So for example, on a given worker node, you may have two different pods. One pod with some internal IP address will run a single container. Another pod will run two different containers. Because in Kubernetes you deploy groups of co-located containers instead of individual containers. Okay, so this is the pod, co-located containers. Okay, so each pod has its own IP address. A pod can have one or more containers. Okay, so now the next step. Kubernetes, like Linux, has different flavors. You may have different providers of Kubernetes. This landscape is quite large, yes, and in my presentation below I will go through the most interesting, in my personal opinion, different flavors of Kubernetes. So, but you can imagine at the end of the day, compare it to, for example, to Linux flavors. You may have Ubuntu, you may have some other distribution like SUSE, etc., Red Hat. By the way, you can see a micro KAS, micro Kubernetes, comes from Ubuntu. Rancher is created by SUSE. Red Hat has its own OpenShift. Yes, but you have also Google Kubernetes Engine, Amazon Kubernetes, Azure Kubernetes services from Microsoft. So you have different flavors of Kubernetes. So let's start with Kubernetes with Docker. Yes, you can run a simple Kubernetes with your Docker app, and using a Docker command line interface, and we are used to that because we are using it very heavily with our experiments with Docker, you can run a Kubernetes within a virtual Linux machine on your system, or directly in Linux if you run it on Ubuntu. Okay, so you have the access to the control plane, Kubernetes Docker daemon, and deployed containers. So yes, it is possible to play with that. But this is the single node Kubernetes which runs in a Linux virtual machine. The control plane components run in containers, and the kubelet runs in the virtual machine operating system. Apps run in separate containers, and you can see deployed containers by invoking docker ps, which is the Docker command for tracking the running containers. Okay, there's also another option, Minikube, a lightweight distribution of Kubernetes. This is the single node only, so you may use it just to learn Kubernetes or test it locally, test your local deployment scripts. So you have once again Minikube command line interface and Minikube's Linux virtual machine as in case of Docker. So this is a single node Kubernetes which runs in the Minikube's virtual machine. If you run Minikubes on Linux, you can deploy Kubernetes directly on OS. The kubelet uses Docker to run the containers, so you need to have a Docker daemon running in the background. Yeah. This is also there is there is also multi-node distribution kind Kubernetes. This is the multi-node. Each node running inside a Docker container, so it's a bit more sophisticated. So you have a Minikube command line interface. You have a Docker running, and each node will run inside a Docker container. You have the control plane with its processes, worker nodes with kubelet. As you can see, this is another container management system instead of Docker, CRIO, within the kind Kubernetes. Master and worker nodes run in containers, apps containers run inside node containers. This is the example of commercial in that sense, because it is run on Google computing platform, Google Kubernetes engine. This is the architecture. So you have the user, you have kubectl, which is the interface to API server. So this is the control plane. These are the worker nodes. Yes, user pods with containers, and you can connect them to Google Cloud services like VPC networking, persistent disk, load balancers, cloud operations, etc. So this is the simple architecture of Google Kubernetes engines. As I already mentioned, you will find something similar on Microsoft Azure and Amazon Web Services. By the way, this is an extremely easy way of Kubernetes deployment. It takes literally a few minutes to deploy compared to hours, if not days, in my first approach of running such a Kubernetes on the bare metal. But by the way, you have working instruction how to deploy it in my course materials in one of the README files. So as I said, also you have Rancher by SUSE, distribution of Kubernetes, or my favorite one. And if I can suggest you to try, I would start definitely with this one, because in my personal case that simply works. Yes, so you can try to deploy using, for example, the course materials I provide you with kind of instructions how to set up a Kubernetes cluster using the Ubuntu distribution microKS microkubernetes.io from Ubuntu. What do you need for this? You need to have 3 machines, 3 Linux servers. One should be quite strong, so I guess at least 64 gigabytes memory just for control plane. Others may be very, very small, extremely simple servers. Let's say do it 2 or 3 such a simple servers, almost no requirements. And then you install the main Kubernetes distribution on the control plane and others setup. It's quite easy as workers. The only difficulty which you should take care about should be the setting up the configuration scripts to manage the communication between worker nodes and the control plane. So, but that's described both in the tutorials here and in my course materials. So that completes the brief introduction to the Kubernetes. That will also open the door for you for running a Kubeflow, which is the system which helps you to manage the pipelines, specifically machine learning pipelines. And this is a very major, very interesting solution, which I strongly recommend you to give it a try in case you would like to really scale up your skills to the large scale deployment of ML DevOps solutions. So once again, thanks a lot and happy coding. Thank you very much.